So welcome to 2016 question A2. The image below shows a bar chart presentation on a paper flip chart. Okay, so here we have our bar chart. The drawing on the right shows the plan and incomplete elevation of a similar bar chart or similar graph and flip chart. Complete the elevation of the flip chart and bar graph. So we want to locate everything here up in our elevation. Right, some of it's already been located first, so I'm actually just going to heavy in some of those edges. Okay, now we need to kind of think about some of our key principles. Okay, we know that the parallel lines appear parallel in all views. Okay, so we can see here the edge of our flip chart is parallel to that edge on the graph. Okay, that axis on the graph, and here the edge again of our flip chart is parallel to the edge, or some of the edge, not all of it shown, but some of the axis there on the graph. So that is telling us that it is something that we can use to solve this, because all of these then are running parallel to the edges of the flip chart. So what I'm going to do is start off by locating the position of these bars on the axis there for my graph. Just project all of those up onto the graph. Projected up already. Now you can see here this diagonal line AB determines the height of our of each bar on our graph. So I can use sliding set squares using my edge of my graph, and I'm going to slide along and draw everything parallel until I hit that line. So this corner here, I need to go up until I hit, right, exactly moving until I hit my green line AB. So it's going to go up to there, so it'll be running up, don't know where yet, I'll be able to turn that. That's onto AB. Let's try this up, parallel, onto AB again, and this will be parallel. And just for the sake of this, I'm actually going to extend on my axis there of that chart. So just going to locate this finishing point of that axis. I'll draw that in heavy. Got my two axes drawn, axis 1, axis 2, or X and Y axis. Okay, and I know that here are the finishing heights of each of those graphs, or each of those bars. Okay, now we also know we can say that here this line, this line, this line, this line, this line, they're all parallel. Okay, they're all horizontal, okay, but they're all parallel as well as the main thing. So we can run horizontal lines until we hit those other horizontal lines we had. We can see that those are in line as well, where they should be. And I can finish that off by running over those parallel lines that I've established. Okay, so that is my graph and flip chart completed. Determine the true inclination of the diagonal AB to the horizontal plane. Okay, so we want to find the true angle that this line AB creates with the horizontal plane. So in reality, it's sloping upward here and kind of sloping backward there in elevation. So we want to find that angle. Sorry, so if that's sloping upward there, we're going to find that angle. So we could take an auxiliary elevation, because that will give us an edge view of our horizontal plane, and then we'll be able to find AB like so, and that will give us the angle. And the other method we can use is to rotate AB. So I might actually do both very, very quickly. So first one is I'm going to rotate AB, so rotate point A around until I'm looking perpendicular to it. So very, very quickly. Either one of these methods would be correct. So that's AB, and we're looking perpendicular to AB now. So project it up onto the line. Alright, so that's method 1. I'm actually just going to highlight all of that so it makes sense here. So AB is being rotated so that we're looking perpendicular to it, and that would be the angle, the true angle of inclination. And the second method, very, very quickly, is we can take sliding set squares, okay, I'll just create an XY line anywhere right here. That's my X1, Y1. So that's an auxiliary elevation. I'm projecting from plan to an elevation. So my heights here, I'm going to take the height of B. Actually, I'm going to project it out first. So A. Okay, so A is resting on the XY line, so here's A, and B, we are going to step off, just extend this on so I can get the correct height. So that height from the XY, I can step that off to here. And that would be the inclination of the angle between my XY line, my horizontal plane, and my and that diagonal line AB. So 2 methods there, whichever one you prefer, you can use. Both will be marked correct.